partitions. In other words, if the homogeneous family is 100, the two partitions are identical. Using this approach, we were able to identify and to create, to create 500 blobs. Specifically, we consider 5 open source systems. And for each system, we create 50 artificial blobs composing by merging 2 classes, and 50 composed by 3 classes, merging 3 classes. Okay? Of course, we focus just on high quality classes because we need a reliable oracle. If you put together and merge classes with low quality, the oracle is not reliable. The experimental configuration, we use some way to experiment different, we use a simple approach to experiment different configuration, changing, for instance, the weights from 0 to 1, or different threshold for filtering spurious relationship. In total, we experimented almost 500 different configurations, and among them we selected the best configuration. Good. The number of blobs is high. We have a process to measure, we have a matrix that measures the accuracy. The number of different configurations experimented is very high, so the result can be stable, can be generalized. So the first solution to our problem, that is parameter tuning, parameter configuration, is use an approach inspired by mutation testing. But what is the problem with this approach? This is not an evaluation. Why? Can you guess why? This is just a way to tune your parameter, but it's not an evaluation because you are experimenting your approach on artificial blobs that by construction could be easy to refactor, because if you put together classes that are very different from each other, probably is simple to split the 2 classes. So we still have a problem. Problem number 2, that is, we need an approach for evaluate the performances of our approach. So Gabriele, of course, studied the state of the art, and he found several papers talking about refactoring, published in flagship journal and flagship conference. You can see here TSE, GECO, TSE, WCRE, and of course all these papers presented an approach for refactoring and also presented an empirical evaluation of the approach. And the evaluation is based on metrics. In other words, is an evaluation, an objective evaluation, that is based on quality metrics specifically. Quality metrics, cohesion and coupling. Well, how to conduct such an evaluation? How to conduct an experiment in general? Okay, if you want to conduct an experiment, if you want to evaluate your tool, first of all you need to have an idea. An idea of cause and effect relationship. This is the first important point when you need to design an experiment. You need a theory, you need an idea that you are able to formulate in an hypothesis. An hypothesis means that you are able to formulate your idea formally. This is very important. Because as we can see later, you use statistical tests in order to reject your null hypothesis that is based on the original hypothesis of your experiment. In order to test your theory, you create an experiment. An experiment that is used, that is designed, that is conducted in order to collect data that can help you in verifying your hypothesis. Specifically, during the experiment, you provide some treatment that you can change in order to verify the effect of the treatment on the variable that you are observing. In our case, we have a refactoring tool a tool that supports refactoring. So your treatment is the application of refactoring method, yes or no. In other words, you have the software system refactored with your approach and the original system. And you want to analyze the effect of the refactoring on the quality of your system. This is the cause and effect relationship. During the experiment, you work on several variables, just to give you an idea of the terminology. And specifically, we distinguish between independent variable and dependent variable. The independent variable are the variable that you can control, and for each independent variable you have the treatments that are the value that the independent variable can assume. So you have the full control of this variable, and you analyze the effect of this variable on the dependent variable. That is the variable that you observe, that you can measure. But an experiment is not easy to conduct. An experiment should be designed properly. And these are the phases extracted from the book by Woolin of an experiment design. First of all, you have to define the experiment scoping, which is the goal of your experiment, the idea, the experiment idea, the planning of the experiment, the operation of the experiment. Then you have to collect the data, analyze the data using statistical methods, of course, but you have also to interpret the data. Then you can present and package the data. Very useful is the replication package, where you put together all the information, all the material necessary to replicate the experiment. And once that you can write, once you have completed the experiment, you can write an experiment report, or in our case, a paper. When you define the scoping of your experiment, you can follow a template. This is not necessary, but could be useful. Specifically in the scoping, you can define the object of your study. So, what are you studying? Which are the purpose of your experiment? Which is the quality focus? So, which effect is studied? Which is the perspective of the experiment? For which one is useful? Which one is useful the result of your experiment? And the context of your experiment. This is very important when you are conducting the study. In our case, the extra class refactoring, the evaluation of the extra class refactoring approach, this is the experiment scoping. Specifically, we have an experiment idea, and this is our experiment idea. Refactoring a block with our approach, that is the cause, constructed the cause that we want to observe, we are able to improve the quality of a software system. Effect construct. So this is our theory. If I apply my approach on this system, I am able to improve the quality of the system. And this is the scoping. So, the object of the study is the proposed approach for extra class refactoring. What are you studying? Your approach. Which is your purpose? Which is your goal? To evaluate the benefits of the proposed approach, because I want to analyze if my approach improve the quality of the software system. Which is the quality focus? So what are you observing? I'm observing the quality of the software system in terms of cohesion and coupling. So I want to measure the quality of the software system considering just these two goals, cohesion and coupling. Which is the perspective? So the result of my experiment could be useful for researchers because I want to give to the research community an idea that graph-based theory and the different measures that we have used can be used successfully in identifying refactoring operation, or for practitioners, more important, because this can be used for the technology transfer. I can give some empirical evidence that our approach works, so we can suggest with our paper to practitioners to use our approach in their company. And which is the context of the study? So, where we are conducting the experiment. In this case, the experiment is conducted on a set of manually validated blobs. So, no more artificial blobs, but we want to evaluate our approach on real blobs, taken from real systems. Manually validated means that there are some peoples that have identified manually that classes, and they have classified that classes as blob. In this experiment can be conducted completely automatic, so we don't need humans, but I will show you in the second part of the tutorial how to conduct an experiment with humans participants. In this case, we don't need humans. We just need a couple of students that manually identified among 1 million classes a good number of blobs, but students are not humans. This is the planning of the experiment. Okay, first of all, you need to define in details the context of the study. You need to define the experiment design. You have to select the experiment variables. Remember, independent variables, and for each independent variable, you have to describe the treatments and evaluate the validity of the experiment. This is the context of our study. So I will show you how to do all these steps in the context of our extra class refactoring approach. As you can see here, these are the blobs manually validated that we used in the context of our study. So we experimented our technique in the context of these 17 blobs manually validated, manually identified. So no more real blob, but no more artificial blob, but real blobs. This is the design. The design is very simple, similar to the previous one. Take a blob, refactor the blob using your approach, measure cohesion and coupling before and after the refactoring. In this way, you can measure the quality improvement provided by your approach when refactoring the blobs. So, if this is the design, which are the variables? First of all, what is the independent variable? What you can control? You can control your approach. In other words, you can control the variable that I call it refactoring, that can assume two different values, that is yes or no. So the system has been refactored, or the system is the original system. Which is the dependent variable? What you are observing? You are observing the quality of your software system. In other words, you are observing the quality metrics. You are observing, in particular, cohesion and coupling. Specifically, we used 3 different metrics. Usually the dependent variable is 1, but you can have also experiment where you have more than 1 dependent variable. In our case, we have 3 different dependent variables because we have 3 different quality metrics that we consider it independently, because we are interested in analyzing the improvement in terms of cohesion, but we measure the cohesion using structural information with the outcome cohesion matrix that is based on the number of shared variables between methods, and also the semantic or conceptual cohesion of a class that is based on the textual similarity between methods. Other than cohesion, we want also to analyze the coupling. Of course, if you split the blob, probably you are able to improve cohesion. Probably you are able to increase cohesion, but you are probably not able to improve coupling. You are not able to reduce coupling because you are splitting. Okay? Why we measure cohesion? Why we measure coupling? Because we want to understand the compromise between cohesion and coupling. Specifically, when you split, you are pretty sure that you improve cohesion. But splitting the method between different classes, among different classes, you also probably increase coupling in your system. So our idea is to understand the trade-off between cohesion and coupling. It's time to sleep, I think. Oh, no, not yet. Well, there is also the validity evaluation. So once we have identified the quality, the metrics that the variable of your system, in our case, the independent variable are the refactoring of the system, refactored system or not refactored system. The dependent variable are the two cohesion metrics and the coupling metrics. You have to perform the so-called validity evaluation. In other words, you have to explain how valid are the results of your experiment. This is one of the, I think it's one of the most difficult sections to write, but it's one of the most important, where you actually need to highlight which are the limitations of your study. In other words, which is the generalizability of your result. How you have conducted the result, have you performed properly statistical test. This is also important. Max said this morning that you have to select properly the tests that you have performed, and you select the test based on the data that you have collected. On the basis of your data, you can have particular tests that you can apply. You have to discuss all this information in the so-called traits to validity. But the more important thing, the most important thing, in my opinion, in this section is to provide information and provide to the rationale of some design choice on your experiment in order to give more information to the reader in understanding the experimental design. Remember that every experiment has some limitation. What is important is to discuss this limitation without trying to hide this limitation. So it's important to say, look, I have experimented my approach on 10 systems. On this system work, but this not means that the approach work on every system. On this 10 system work pretty good, but could be that on another system with specific characteristics my approach does not work. The validity evaluation is usually performed before running the experiment. So this is also important because you need to analyze the limitation of your study before running the experiment, because the limitations are due to the design of your study, not to the result that you achieve. In our case, in case of extra class refactoring, these are the traits to validity. And specifically, the first trait is related to the number of blobs, because we have experimented our approach on just 70 blobs. If you look at this number, 17 blobs means on 17 classes. That is a number that is quite low. But if you think that usually on real system you cannot have a huge number of blobs. Number of blobs is quite low. This is a good number. So 17 is a good number, especially because these blobs were manually extracted and manually identified. So the set of blobs is quite reliable. Another trait is represented by the metrics used for the evaluation. Remember that our experimentation is metrics based. Specifically, we applied our approach and we measured the quality of the system before and after the refactoring. And we used 3 different metrics: LCOM, C3, and MPC. But LCOM is based on the number of shared variables. C3 is based on the textual similarity between methods, and MPC is based on calls between methods. In other words, we are using for the evaluation metrics that use the same information that we use to identify the relationship between methods. In other words, what I'm saying here that you can have an improvement of these metrics by construction, because your approach is based implicitly on these metrics. However, these metrics are widely used as metrics for measuring cohesion and coupling, so the experimentation could be conducted, even if there is always a trait that is represented by the way how we construct the approach. There are other steps that you have to perform in order to do an experiment, that is execute the experiment and collect the data, run the experiment. In our case, running the experiment is very simple. You have just push a button, because of course you can build a tool that make your experiment completely automatic, in the sense that take the blob, extract the blob using your approach, compute quality metrics before and after.
Excuse me.
Yes.
What's the meaning for manually validated in this case?
Manually validated,
yeah,
means that the students analyzed the classes and manually identified the blobs. First of all, of course, they did not analyze all the classes of the system. First of all, they compute quality metrics on the system. So for each classes, they have information on cohesion and coupling. Then they look for cases where cohesion is very low, coupling is very high, the number of lines of code is very, very high. There is a book by Lanz and Marinescu where there are some indication on how to identify anti-patterns.
okay.
Blob is a kind of anti-patterns based on metrics. So they measure several metrics for each classes and identify warning cases. So the manually identification is just based on warning cases. Warning cases means that you have a class that is that has a huge number of lines of code.
Not just a class with a huge number of methods.
No. They consider different aspects.
Okay.
So cohesion, coupling. Also, another important characteristic of a blob is the usage of data classes. So the number of data classes used by the blob. The higher the number of data classes, the higher could be the number of responsibility.
Access to public instances.
Of course, yes. But if you have a blob, for instance, that access to the data class student and the data class exam, probably this class manage student and exam.
Okay.
Of course, they focus on a set of classes and not on all the classes of the system. Yes?
In this case, students are used to evaluate the results or the...
No, just the oracle.
Okay.
So, they just define the set of blobs where we applied our approach.
Because using students that are not experienced programmers, so their feedback is not... If they are not humans, how can we say that?
This is a very good point, and we discussed this point in the second part of the tutorial. But still, this is a trick in this experiment. In the sense that I am a student, and for me this class is a blob. But if I don't have experience, I can make a mistake. So the idea is to ask a group of students to identify blobs. Then organize a meeting in order to discuss all together which are the blobs for him, which are the blobs for her. In order to define a comprehensive oracle given where the feedbacks are, where the identification is not only based on just observation by student, but by a student, but a group of students. In order to make the oracle more relevant. Yes?
But you did not propose how to split up the blobs.
No. They just identify classes with the quality problem. This class for me is a blob and should be refactored.
But how do you know that your approach should split up the correct parts?
This is a very good point, but it's not part of this first experimentation. In the sense that we just refactored the blob and evaluate the quality improvement. So we evaluate the quality of our refactoring operation, just measure cohesion and coupling. Okay? After running the experiment, after having collecting the data, you just need to analyze and interpret the results. And here it is important to select the appropriate test. Or, of course, you just also need the descriptive statistic of the result. As Max said, showing just median, mean is not enough. Box plot could be useful, or median, mean, and standard deviation. In our case, remember that, which are the results? Remember that we have three different measures. that is lines, that is LCOM, C3 and MPC, running our tool on the blocks identified by students and computing the software quality, computing quality metrics before and after the refactoring. These are the results. We have a good improvement of LCOM, so we are able to improve cohesion, structural cohesion. We are able to improve a lot the semantic cohesion, and we also increase the coupling, but this was expected because I'm splitting a class. Remember that the perfect scenario for having the coupling 0 is to put all the methods together in just one class. It's a monolithic approach, cohesion is 0. But when you split, of course, you have some calls between classes, and so you have some coupling between the classes. So, the results are good, of course. We have an experimentation based on artificial blobs to tune the parameter. We have identified, using such an experimentation, the best configuration parameter. Then, based on the state of the art, we have performed an experimentation based on quality metrics. I want to analyze the benefits of my approach. I have a set of blocks, so I have a set of classes with quality problems. I can refactor in this class, and I can measure the quality improvement in terms of coupling and cohesion. The results are good, and of course, we submitted this paper on April 2012, of course, to empirical software engineering. The paper was 32 pages, the first version of this paper. On September 2012, we got the first evaluation, but you will know the result of this first evaluation after the coffee break.